controlled gunnery targets in World War II. These are the four aircraft I'll be talking about. The earliest is here, the second is here, third is here, the fourth is down in the right hand corner.
You gonna take it home now?
What?
The fresh
The earliest
I don't
American
have it.
experiment radio-controlled
Yeah, I can't
aircraft was
think
in
of it.
1924,
There's a
where Curtiss seaplane
Okay.
took off
Ed Bert's old
by
library.
remote control, radio
Okay.
control,
That's the one you want to-
flew around for
Don't
9
open up
minutes
all my
and
stuff.
landed. It managed to hit something on landing and it sunk. But that was the first complete
I'll
circuit.
download them.
And this is 1924. The British were quite active trying to figure out radio-controlled aircraft or remotely controlled aircraft. And this is the Fairy Queen. This was an aircraft, again, full-size aircraft. They made 3 of them. The first 2 failed on launch, but in 1932, one was launched from the catapult, flew around for 9 minutes, and successfully landed in the water. What's of most interest in 1933, in the Mediterranean, they launched this exact same aircraft and flew it around for an hour. The home fleet shot it. They did not hit it. The airplane landed and was recovered, and this was a huge wake-up call for everybody that the anti-aircraft gunnery that was going to save capital ships wasn't really up to snuff. And in the American realm, there were a number of aircraft that were used experimentally. The radios were heavy, the actuators were heavy, the batteries, if they had batteries, generators were heavy. But there was a selection of aircraft. But you'll notice that so far, all the aircraft were either seaplanes or tri-gear aircraft. And the reason for that was the controls moved very slowly. So you couldn't really take off a tail dragger. You needed a lot of space to control the aircraft. If you had a seaplane or a tri-gear aircraft, certainly for a seaplane, you could point the aircraft into the wind and take off. And then the land planes, it was much easier to link the nose gear with the rudder to keep it on track to take off. First mass-produced radio-controlled aerial targets were again British, called the Queen Bee. This is 1935. Again, full-size aircraft. They had pneumatic controls in them. This is the control being done from the ground, but they were also done over the water. They made at least 400 of these, and they used them all during World War II. The issue was with this is it's a full-size aircraft. It's expensive. It's hard to maintain. It takes a lot of space. And so there were efforts by both the Germans and the Americans in the late 1930s to build a small radio-controlled aircraft for gunnery target purposes. So to teach people how to lead and elevate guns to protect the military forces. So this is the German aircraft that was quite small, only 7 horsepower engine. They made about 20 of them. They weren't horribly successful, but notably they did put a camera in it, an automatic camera, and try and use it for reconnaissance. I'll point out that all the aircraft I'm going to talk about tonight were line of sight, so it's radio controlled. Nothing was autonomous. It was all controlled by a pilot on the ground, and they had to see it to be able to control it. So here's the geniuses that figured out the American program. That was actually a British guy. He was a famous actor in the silent era of films, but he had an interest in aviation, and he owned a hobby shop in Hollywood, California. He was the visionary that thought, I need to make a radio-controlled aircraft that people can shoot at so we can learn anti-aircraft gunnery skills. This was one of the geniuses he hired, electrical engineer named Kenneth Case. And the third engineer was Walter Reiter. Walter Reiter designed engines and other things. He worked for a couple of aircraft companies. And it's his company that made the engine right over there, which I'll talk about shortly. And then because everything runs on money, and Paul Whittier was the financier for this effort. And it was really Denny's idea that we really need to make an effort to make these aircraft controlled from the ground. 1935, this is their first experimental aircraft. Looks very much like a model airplane, 9-foot wingspan. It had a two-stroke, two-cylinder engine with parts scavenged from an outboard motor. They demonstrated it to the Coastal Artillery Command in December of 1937. The demonstration was a failure, but it made an impression with this good colonel. So back to the drawing board. They now were working on the RP2. They called them RPs for radio plane because they were radio controlled. This is the second iteration. They made the wingspan a little bit bigger. Again, had a demonstration at one of the dry lakes, and it too was a failure. However, this Colonel Keel was greatly encouraged and gave them the equivalent of $327,000 in today's money to develop 3 aircraft to deliver in a year. And so Denny and his team committed to that. Next iteration is this RP3. So now it has a little bit bigger. And you notice this is the parachute hatch. It has a hatch in the back of the aircraft that could be released on command. It popped up, pulled the ripcord, and the aircraft would come down under the parachute. So it could be reused if it wasn't shot down. And this was patented by Ryder and Kenneth Case. So in Riverside, California, in March of 1938, oddly enough, everybody knows you can control a radio control aircraft with your phone now. Well, guess what? That's old news. These aircraft were controlled with an old-fashioned phone dial. That was the best they could do. Things got better, but this is how they started out. And you can only control one function at a time. Now, these aircraft were 2-channel. The engines ran full out until they ran out of gas or were killed. It only had rudder control and elevator control. It had a lot of dihedral in it, so if you put some rudder in, it would turn. It would go down. It was able to turn with the dihedral. They had a single rotation propeller. That used to be on the front of the engine here. But to do it, so let's say you want to turn to the left. You had to dial left, and the rudder would start to move. And then you had to dial stop, and the rudder would stop there. And once the rudder stopped, it would slowly go back to neutral. Now, if you just put the rudder in, the plane's going to want to curve down. So you need elevator. So then you have to put your finger on up, dial up. And the motors that drove the elevator make the elevator come up until you told it to stop. Then you had to hit the stop. And just to make it even more interesting, the elevator stayed where you left it. It didn't self-center, so it could be used as a trim function. So now you've completed your turn, but you're climbing. Well, now you have to use down elevator. 1, 2, 3, dial stop. So you had to be way ahead of the airplane. It was very awkward and very difficult. Eventually, after the early experiments, they went to a joystick, but it was the same functionality. You couldn't put the joystick in a corner. You had to do one thing, come back, other thing, come back, left, right. The other thing they had trouble with, huge amount of trouble, and you can see this crash, the airport, and the parachute never came up, was engine torque. So the engine wants to spin one way, propeller spins one way, wants to turn the airplane the other way. And this was a huge problem. Particularly at low air speeds, which is what they're flying off a lake bed, and it took a while for these to accelerate up. So they had a lot of crashes, and they didn't know why. What do we need to fix? So one thing they decided to do was make counter-rotating propellers. So one propeller rotating in one direction, in the other direction, equals out a lot of those evil forces that wanted to drive the airplane sideways. And this is the engine they designed. This is called the Sidewinder. These are 24-inch propellers, power sections in the middle. There's a gear train here, and they're phased so they don't run into each other. Well, one propeller is going in one direction, the other propeller is going in the opposite direction. So those forces equal out.
B-38, huh?
Yeah, well, so those are counter-rotating propellers. So they do spin in different directions, but they're not kind of near the same power axis, let's say. So these are actually contra-rotating propellers. So this is the RP-4. This is April of 1939. So World War II started September 1st of 1939. So this is way ahead of the game. 12-foot wingspan, 12-inch cord, maximum speed about 70 miles an hour, joystick control, and it flew for about an hour on 0.75 gallons of gas. Can people hear me?
Mm-hmm.
All right. Much easier. So here they are out at the lake bed trying to figure this all out. And what they found was their catapult wasn't strong enough. It was coming off the catapult. It wasn't still up to flying speed, sloppy controls. It couldn't work. But the also thing they struggled with was, how do we trim this to fly? Where should the center of gravity be? What should these surfaces, angle of incidence, or the amount of trim on various functions? So they built the poor man's wind tunnel, which was a 1930 LaSalle with metal rigging on the front. And the aircraft was tethered, but it could move 2 feet this way, 2 feet this way. It could be controlled from the car. And, this was good for about 90 miles an hour running across the desert. And so they could start the engines and basically fly the aircraft within this trapeze to figure out how they were actually going to do it. And so in May of 1939, this is the RP-4. These are the first three aircraft accepted by the Army Air Corps. And all three launched, landed by parachute. They got packed up the next day, got sent off to Ohio, and the radio plane company was incorporated later in that year.
Have been capable of causing itself. By the 1930s, when this little target drone was developed, one of the bug's major deficiencies, its lack of guidance, was being looked at. Like today's model planes, the aircraft made a handheld radio control unit. Interestingly,
there's the telephone dial.
This unit employed a telephone dial to send the selected signal to the drone. As with all target drones, there was a balance between the disposability of the aircraft and the sophistication necessary for it to do its job. And in this case, as a target, the plane didn't really present a simulation of an enemy aircraft. However, ground troops could fire away at it and presumably learn something before it was blown away.
So the parachute button would kill the engine and throw out the parachute. Actually, it was a dead man switch. So the parachute hatch was spring loaded, and they would put it down, and there was a solenoid that would hold it in place as long as the electricity was working on the aircraft, and it was getting a signal from the ground-based thing. Once it didn't get a ground-based signal for 4 seconds, it would turn itself off. The hatch would go. Really clever. And now we get to the next step. So the military bought 50 of those and toyed with them, tried to do some teaching, but they really didn't like the engine. It wasn't fast enough. Let's make a better one. And this was the result. This was flown as a prototype 4, May 1st, 1941, so 5 months after Pearl Harbor or so. And production started early the next year. It was, this is what it looked like. It was 12 foot in wingspan, It flew about 85 miles an hour. It weighed about 108 pounds. It would fly for an hour on just under 2 gallons of gas. And again, the engines made about 6.5 horsepower.
So you had two propellers on it. One was pitched different than the other.
No, they were actually the same pitch. So there's a whole science to this, but basically at lower air speeds, contra-rotating, lower meaning less than 200 miles an hour, the propellers can be pitched about the same and remain efficient. Once you get going faster than that, the pitch of the propeller has to be different, and it's counterintuitive. It has to be a lower pitch, but that's a discussion for another time.
So were these on the same shaft or two separate?
Yes. So this is the actual engine that's on that drone, and if you twist the front, you see the back turns the other way.
Oh.
So we'll explain that in a minute, but yes, it looked just like this.
Huh.
Because the planes were flying faster, they had to improve their wind tunnel. So they bought a V-12 Packard limousine, 150 horsepower, good for 120 miles an hour. Took everything out of it and just put the trapeze on the front. And again, learned about trim and incidences and thrust lines, all of that. So they built about 3,700 of these drones, of this type of drone, which is called the OQ-2. I should mention that the Army called them OQ-2As. The Navy called them TDD-1s, for Target Drone Denny number 1. And the companies called them RP-1 through 5. So they have 3 different names.
Mm-hmm.
They made less than 50 in 1939. They were building 40 of these per day in 1945.
This is in Ohio?
2 places. These airframes were made either in Joliet, Illinois, at the Globe or Frankfurt Aircraft sailplane plant in Joliet, or in Burbank, California. And at the time, Norma Jean Doherty worked in the plant. She was 19 at the time. She was a dope inspector, amongst other things, and she went on to become Marilyn Monroe. This is a lineup of the assembly with welding up the frames. These were steel frameworks, all gas welded. Large number of women, putting the covering on, all these operations, cutting and sewing fabric, a jig for repairing them, a whole lineup of them, cranking them out, and the whole airplane could be put in a 2 foot by 2 foot by 108-inch box. The wings, the engine, everything, and shit. This is what it looks like on the inside. Here's the engine with the counter-rotating propellers, fuel tank right on the CG. This is a battery box that weighs about 16 pounds. It's got a number of different types of batteries in there to power the engine and to power the radio receiver. There's a bungee to open the hatch. And back here is the servo. And there's linkage arms that go to the elevator and the rudder. And this is a parachute hatch here. It's folded and inside it's covering. To do a training organization had all of this, one transmitter, spare transmitter, 1 catapult, 12 aircraft, an officer and 7 enlisted men. This is a catapult. This is the generator and basically the electricity conditioner to allow the radio transmitter to work, as well as batteries for backup. You'll notice our pilot has earphones on. What they did to make it better for the pilots to understand what was going on in the aircraft is each of the functions, up, down, left, right, had a different tone. So when he's doing the dial of the joystick, it would beep for one and beep for another. So it helped him keep track for how long that motor was running, as well as what direction it was going. And for those that fly radio control aircraft, they also had buddy boxes, which is basically a separate radio control box. So a student can stand next to him and he's got a button. He flies, I fly, he flies. Pretty ingenious for 1941. This is what the joystick looks like. Again, only one function at a time. These radio systems were made in Chicago. This is the receiver. So this is a miniaturized receiver of the early 1940s. It had 9 vacuum tubes, which is kind of a nightmare, but they got away with it.
You know who made
Little Radio Company in Chicago, Illinois. And this is what the servo looks like. And basically, these are 6-volt motors with a gear train. And when it was commanded, the motor would spin it up, and this arm would move ever so slowly one way or the other, and the same with the elevator. These were made in Princeton, Indiana. And the receiver, batteries, battery box, and cables weighed 16 pounds. So, you know, it's what it took to get it accomplished back in the day. And the batteries were good for about an hour and a half of flight. This is a catapult, weighs almost 900 pounds. It had 700 pounds of tension when you wound it up. And it was adequate to launch a 143-pound aircraft at 65 miles an hour when it came off the catapult. So that gave you some control authority because it was already flying at a pretty good speed. However, the manual says your job is to have the crew trim it right and don't touch anything until it goes to 300 feet. So this was up at Oshkosh, all wood wings. And again, back to the clever nature of all this, it doesn't have ailerons. So you could put this wing on that side of the airplane, or vice versa. The vertical stabilizer component is the same as the horizontal stabilizer component on each side. So this is 1, 2, 3. They're all identical. So you can take a pile of parts and get pretty far along building another airplane when these are getting shot down.
So it's a symmetric airfoil on the main wing?
It is. It is.
Well, what would make it roll if it didn't have aileron?
Dihedral. So these had 5 degrees of dihedral. So when you put rudder in, with that amount of dihedral, it will turn. And that was the key. If you have a straight wing or nearly a straight wing, it kind of mushes sideways. And that's why you see some of these really old-time planes, lots of dihedral, because it's also self-aligning. When the plane has dihedral and it's making a turn, well, that bottom wing has more lift than the wings in the air. So it's going to tend to push that wing back up all by itself, aerodynamically. So here's some artwork. This Dottie left a great picture of herself. She was an inspector. Don't know anything beyond this. She signed it and inspected it on November 26th of 1943. So pretty neat. And there's little bits and pieces like this all over these. Parachute was 24 foot in diameter. It was rayon. It was not silk. And a 20 foot per second descent rate. This is the engine that's shown over here. The biggest question for this engine, because it has the contra-rotating propellers, how do you get one to turn one way versus the other? And this is what it looks like if you take the front case off. So this is basically the crankshaft, this Pinocchio nose, and the front propeller just attaches to that. That spins one way. The crankshaft has this big gear. That gear interacts with that gear, turns it the opposite direction. That gear meshes with this gear, it goes back the same way as the forward propeller. When you take this cover and flip it over onto all of this, this gear interacts with this gear and it turns the opposite direction. This is separate from the power section of the engine that has its own oil supply. And this is a 6 horsepower engine. There's 2 bearings in there that you could run a truck on.
I don't understand that.
Well, you know. So the ignition system is like a 1970s car. You need to have spark advance so the engine can get up to its 3,600 RPM. And these are flyweights. And when it gets past 2,000 RPM, these flyweights come out, it turns this cam, and the spark is advanced 20 degrees. So the mechanics didn't have to do anything except start the engine and get the proper RPM. Now I'll add, because this is only a 2-channel airplane, the engine runs full speed until it runs out of gas or gets shot down. There's no throttle. So they start the engine on the catapult and it flies wide open until it's done.
Free flight.
Yeah. And because magnetos are expensive and precision devices, they used a battery, a points and what's called a dual coil, which will fire both the spark plugs at the same time. That's the design of this engine. It's much like an outboard motor. So there's a lot of detail, and you don't have to pick up on all this, but this is a disposable target made to be destroyed and mass produced. The military required that the engine have a 50-hour type test. So they sent the engine to Wright Field. They ran it wide open for 50 hours and measured everything and said, it works pretty good. So anyway, it would make 6.5 horsepower at 3,800 RPM, about 4,000 at 4,200 is make about 7.5 horsepower. Crankcase never got higher than 150. The cylinder head never got higher than 380, and it burned about 8 pounds of fuel per hour. So I was able to find a very old original manual. So it says great care must be taken when you hand start these engines because they accelerate fast enough. This is true.
Will they kick back on you?
No, they just come around fast. They don't, because you start them at top dead center, they don't really kick back so much. There is no danger of injury from the rear propeller. It adds only a mental hazard. This is not true. And an engine hit by gunfire might be expected to fail. So they covered all the bases in this manual explaining the operation. So what is all this about? The idea is that you can take a subscale aircraft, and that's what OQ means. OQ means subscale unmanned. That's the secret code. So subscale means, any scale you want, but not full size. And the Q means unmanned. Target flying at 200 yards away at about 85 miles an hour is an excellent representation of a full-size aircraft flying close to 300 miles an hour, 500 yards away. So the gunners can learn to lead and elevate to shoot down a maneuvering aircraft. That's the whole reason for all of this. And it's cheaper. So here's a setup. They launch them off of catapults. You see, this is a ground-based unit. They did this in Texas. They did it in California. I think they did it in New Mexico. And these are the patterns that would fly. So the gunners are basically where the blue is, and they're shooting towards the top of the slide. These lines are the maneuvering aircraft. And the gunners were only supposed to fire at the aircraft when it was red. So this is somebody coming right at them. That's the only time they can fire for this training pattern. This is crossing. They can only fire when it's red. And this is another kind of oblique. And this is another crossing pattern, but this is more parallel to where the gunners are. They dyed the tips of the bullets different colors. In general, the bullets went through the aircraft and really didn't destroy it for the most part. And so after the aircraft landed, assuming it landed, you could count the colors. There's a method here, and you could figure out how you did.
You know which caliber?
50 caliber, 20 caliber. Yeah, stay tuned. So here's one coming off a fast motorboat. Here's another one. So the OQ-2A is the one always with the two propellers. That's easy to tell. Here's damage. Bullet came right through here. This was shot down, obviously, but again, you can take the parts and kind of put together another aircraft from the wreckage. One collector has a bullet-scarred cylinder, so there's actually some fragments of the bullet as well as the scars. Okay, so it may be a little hard to see. There is no sound with this, but this is probably Fort Bliss in Texas. So here they are folding the parachute very, very carefully. Parachute goes into the spring-loaded box that they attach hatch right before they leave. Here they are off to the range. You get the strong guys to winch this all back. You start the engine. So here's the controls. So here's the movement. See how slow the rudder moves? And the elevator is quite slow. And again, the rudder returns to center. The elevator does not. And he's got his headphones on. And then when he pushes the button, so there, it's starting the engine. Ready, set, go. Another launch. So here's the guns on the right. Different color bullets for the different shoot. Here it's coming right at you, right overhead. So again, this is 12-foot wingspan. Some views it looks pretty good. This is 50 caliber. Now you can see these smears, these streaks like shooting stars. Those are tracer bullets. With every tracer bullet, there's 4 other bullets with it, because they usually put tracer, 4 plus 1 tracer plus 4 other bullets. So as you can see this flying back and forth, the sky is absolutely filled with lead. And at least for these films, nobody's getting hit.
Mm-hmm.
They tend to be shooting behind the aircraft. They really need to be shooting here. End of the run, they push the button, the engine dies down, and comes by parachute.
They're saving taxpayers' money. That's what they're doing.
Yes, well, I'll get to how much these cost. And they were a good deal, but they weren't cheap. And you can see the dead cat bounce. It comes down. The landing gear for this aircraft is really to absorb the shock of it landing and not break anything, but also save the propellers in the engine. It's not really for taking off and landing in the traditional sense. So this gentleman, Norm Smith, he got one of these. Don't know where. Restored it. But put a modern radio in it, a steerable tail wheel, and a throttle carburetor.
You just turn the volume up on the TV on the side.
It's the original engine, the original propellers, but it's 30 pounds lighter than it was when it was in service.
My name is Norman Smith. I'm from Orlando, Florida. This airplane is a World War II target plane that at that time it was called a radio plane.
Nice soft gear, and it comes. So collector was able to locate an original sales receipt for this. And the cost was $1,256. This is $1943. And this was for the aircraft, the engine. It wasn't for the electronics that went in the aircraft. That was supplied as government furnished equipment.
Like Garvin, right?
By the Signal Corps, but so you can go through. They got the cost of the propellers, which I think was $5 a piece or something.
Mm-hmm.
But the factor is about 13-fold. So if you do the math, this aircraft could be purchased in 2024 for about $23,000. So they weren't really cheap, and that's before you get to the government furnished equipment. P-51 Mustang fighter was $59,000 in 1943. So if you think of it, you can get somewhere around 30 to 45 of these target drones for the cost of a P-51 Mustang.